Will Trustee and Chairman Alan Leventhal escort our honored guest to the podium?
Mr. President.
Mr. Leventhal.
Mr. President, I have the honor to present Stephen Chu for Boston University's honorary degree.
Born into a family of accomplished scholars with illustrious achievements to their names, you felt from an early age that you were destined for a less glorious path. In fact, you have used the term academic black sheep to describe your place in the family during your high school years. Well, you may be the first academic black sheep in history who went on to win a Nobel Prize. As an undergraduate at the University of Rochester, your affinity for both mathematics and physics led you to the conclusion that you should become a theoretical physicist. But as a graduate student at the University of California at Berkeley, you discovered that you enjoyed working in the lab far more than working on theoretical problems. An experimental physicist was born. You went from Berkeley to Bell Labs, then one of the country's preeminent private research and development facilities. There you said, we had no obligation to do anything except the research we loved best. In your case, doing what you love best inevitably leads you to ask yourself if you ought to be challenged yourself in different ways. You answered that question by leaving Bell Labs after 9 years for Stanford University and the opportunity to work with students. Teaching is also a path in lifelong learning, a quality which has been one of the hallmarks of your career, leading you to changing fields every 5 or 6 years, moving from atomic physics to laser spectroscopy, polymer physics, and molecular biology. Today, you have taken up a challenge that has consequences for the very future of our planet, developing sustainable, carbon-neutral sources of energy. As director of Lawrence Berkeley National Laboratory, you're using your leadership position to mobilize the resources of science, industry, and the government to addressing the issue of building a secure energy future. You speak with passion and conviction about renewable sources of energy that can be extracted and used without deadly consequences for the environment. Your Helios project is the new gold standard for research into alternative sources of energy, from wind and solar technologies to the development of biofuels. We are not there yet, but with your vision, leadership, energy, and imagination, we grow closer to solutions every day. Stephen Chu, in recognition of your mobilizing leadership in seeking scientific solutions to the energy crisis facing our planet, Boston University proudly confers upon you the degree of Doctor of Science, honoris causa. I now call upon Stephen Chu to deliver the 134th commencement address of Boston University.
Thank you. President Brown, trustees, faculty, guests, and of course students, I'm truly honored to be here to give this 2007 commencement address. So to the class of 2007, I congratulate you on your achievement. In the tradition of all commencement speeches, I'm charged to give advice to graduating students. However, unsolicited advice is rarely valued and almost never followed. And this is a cross that all commencement speakers must bear, so I'll push on. You should first thank those people who helped finance your education. If you are on a scholarship or fellowship, thank your sponsoring institution. More likely, you might have been on a fathership or mothership. Thank your parents. Your parents invested in your education for 2 reasons. 1, they love you. 2, they don't want to support you forever. They may cherish this day more than you. You should thank your favorite teachers for their clear and scintillating lectures. However, at the end of the day, the things you will understand best are the things you have taught yourself. Furthermore, a genuine understanding of anything you read, hear, or see occurs when you've translated the experience into your own personal language. During this reformulation, you will be transferring intellectual knowledge in your head to an intuition that lies in your gut. In giving thanks, I should also warn you soon-to-be anointed alumni of yet another thank you. But before I do that, I have to set the scene. This is the final scene in Casablanca. Ingrid Bergman, Humphrey Bogart, and they are planning to run away together, but at the last minute, Humphrey Bogart turns to Ingrid Bergman, Elsa, and says, if you don't get on the plane to rejoin her husband and his resistance, you will regret it. Maybe not today, maybe not tomorrow, but someday and for the rest of your life. Well, maybe not today and maybe not tomorrow, but someday and for the rest of your life, Boston University will be asking you to thank them. In my advanced age, I have realized that apart from my family, my college experiences at the University of Rochester and UC Berkeley have done more to shape my life and worldview than any other influence. If you become successful, you should thank Boston University. And if you're not successful, you will still be part of the BU family. This was not a paid announcement. All I ask is I have no earned degree from BU, and I hope that an unearned degree does not put me on your mailing list from here on in. Here's some more unsolicited advice. You will discover that your life will be a series of random events. It's a good idea to plan, but in the end, your life will unfold differently. Indeed, the entire world around you will unfold differently. When I was a small child, we were told that the continuing exponential growth of the world's population would lead to mass starvations and other Malthusian disasters. In a half a century, the world population has grown from 2 billion to over 6.5 billion people. But modern agriculture has given us the capacity to feed those people. People are still starving, but not because of our capacity to grow food. While the population more than tripled, the amount of land used to grow grains has gone up by less than 20%. Also, the population is no longer growing exponentially. And indeed, the world population is expected to peak at less than 10 billion people. This was a total surprise, but it turns out that as people get wealthy, they have fewer children. This behavior cuts across all cultures. I suspect that it has something to do with late-night TV. As an interesting data point, the blackout of the city of New York decades ago led to a mini baby boom 9 months later. On a personal note, as you heard, my career did not go exactly as planned. I intended to become a theoretical physicist, but ended up doing experimental work. By the way, the experimental work of my thesis and postdoc was to verify a theory that unified electricity, magnetism, and the forces responsible for radioactive decay. One of the authors of that theory is a BU professor, Shelley Glashow. At the end of my experiment, I was rewarded with an assistant professorship at Berkeley. 7 or 8 months later, Shelley was rewarded by a trip to Stockholm. But instead of staying at Berkeley, I went to Bell Laboratories and then to Stanford. And during this time, I began a slow descent from the loftiest heights of fundamental physics to learning how to hold on to atoms with laser light, and finally to a wannabe biologist. 3 years ago, I have reached rock bottom. I am now an administrator. I left a good life at Stanford as a Stanford professor to become a harried director of the Lawrence Berkeley Lab because of my increasing concern about the energy problem. And I truly believe that this problem is the single most important problem that science and technology must solve in the coming decades. Our planet has warmed up over a degree, and it's predicted that in the next century, it could warm up another 1 to 6 degrees. Now, let me have a caveat about these predictions, and for that I have to turn to the greatest American philosopher of the 20th century, Yogi Berra. He said that predictions are hard to make, especially about the future. Having said this, let me tell you of a few of the predictions. The average temperature, as I said before, will increase by between 1 and 6 degrees. But what does this 6 degree difference really mean? During the coldest parts of the recent ice ages, the world was 6 to 8 degrees centigrade colder than it is today. In those times, an ice cap covered all of Canada and half of the United States, down to Ohio and Pennsylvania. In a world 6 degrees hotter, Greenland will be green and the oceans will be 7 meters higher. The Earth will be a very different place. There will be more frequent heat waves, rainfalls, droughts, tropical cyclones, and extreme high tides. Climate change doesn't mean gentle warming. It's more about violent swings, like rain in May and June. Perhaps the first serious consequence will be water shortages caused by climate changes. Much of the world's mountain glaciers are melting. Water storage in the form of snowpack, glaciers, and alpine forests are a critical part of the storage and moderation of water supply. It's been predicted that the Sierra snowpack in California will decrease between 30 and 70% in an optimistic scenario where the carbon dioxide remains below 500 parts per million. I personally don't think we can keep it that low. In a business as usual scenario, the forests and snowpack of California will be mostly gone. Sometimes reporters want me to tell them that catastrophic climate change threatens the very existence of life. I tell them not to worry. The good news is that life on Earth is very robust. The microbes and insects will always adapt. Polar bears and poor people will have a rougher time. So, how sure do we have to be in order to actually act now? My position is even if half those predictions have a 50% probability of becoming true, I think it would be prudent risk management to take immediate steps to mitigate the risk. If someone told you there was a 50% chance your home will burn down to the ground, would you buy fire insurance? So the decision quickly boils down to the price of disaster insurance and if we really believe these terrible things can happen. So now let me turn to what the Lawrence Berkeley National Lab is doing about the energy problem. For those of you who don't know, the Berkeley Lab is a science laboratory run by the University of California for the Department of Energy. It has a budget of $500 million a year. We do no classified work at the lab. In its 75-year history, 11 of its employees have received Nobel Prizes. 9 of those scientists did their work at the lab, and today, 3% of the membership of the National Academy of Sciences work at the lab. I took the job with the intent of enlisting some of the brightest scientists at the Berkeley Lab and at UC Berkeley to divert their intellectual horsepower to helping solve the energy problem. I'm happy to say in my new career as cheerleader and master kibitzer, it's paying off. Dozens of scientists at the Lawrence Berkeley Lab in Berkeley have been planning for over 2 years how to use their expertise to help solve the energy problem. We've had teach-ins, workshops, open mic forums, and indeed weekly lunch meetings that continued over a 2-year period. During this time, the formulation of a new set of ideas has been terribly exciting to watch develop. Brilliant fundamental scientists, when excited about a challenging applied problem, have become brilliant applied scientists. The University of California, Berkeley Lab, and the University of Illinois have recently been awarded a $500 million contract by BP, formerly British Petroleum, to develop better ways of producing fossil fuels. We are also preparing proposals to try to convince the government, foundations, energy, and private donors to fund a multi-pronged attack on other ways of solving the energy problem. Now, how do we actually go about solving the energy problem? First, let me put a scale of what we're up against. If you look at people in the United States, the average energy consumption per capita is 350 billion of joules of energy per year. Now, only a physicist knows what a joule is. And in fact, most physicists don't have in their gut what this really means. So I will translate. In pre-industrial revolution days, a measure of wealth is the number of servants or slaves you had working for you. So when converted to the energy need to feed and clothe the servants, this is an equivalent. The average man, woman, child in the United States has the equivalent of 100 energy servants working for them 24/7. This is the fundamental basis for the wealth we enjoy, and the energy is the modern-day equivalent of servants or horses. China has 10 energy servants working for each person. And you might ask, is it possible for a world of 10 billion people to sustain a similar lifestyle as the United States? I actually think the answer is yes, if we become smarter in our use of energy and in development of new carbon-neutral sources. So, what are we doing on the supply side? First, on the conservation side, there is a 30-year history in the Lawrence Berkeley Lab of leading in ways to conserve energy. The compact fluorescent light bulb was essentially invented at Berkeley Lab. Double-pane windows where one pane is coated with an infrared coating that reflects the heat was also developed at Lawrence Berkeley Lab, and many other things. But we are also now harnessing our basic scientists to work on the supply side. Physicists and chemists are working to develop a new class of nanoparticle solar cells that can lead to wide-scale deployment without subsidy. The basic ingredients are actually there, and all we need to do is to coax the nanoparticles into self-assembling in an orderly way. Lowering the cost by a factor of 3 or 8 is needed for wide-scale deployment. Biomass offers a hope in creating an alternative to oil. Corn is definitely not a solution, but in Brazil it costs less to run your car on sugarcane ethanol than on gasoline. I believe we can breed plants that will be much more effective in converting sunlight, carbon dioxide, and the precious water and nutrients into biomass. Already, wild grasses grown on non-irrigated, non-fertilized land in Illinois has yielded enough biomass to make 10 times as much ethanol as an acre of corn. We are understanding the inner workings of microbes, and we want to use the same technology to develop new microbes that break down the cellulose material into transportation fuel. We also must develop a cost-effective, safe means of trapping and sequestering carbon dioxide that is emitted from power plants. There is even a possibility of using waste heat or other surplus energy from power plants to grab carbon dioxide out of the air and sequester it in stable geological formations. However, for this technology ever to be deployed, the world has to put a price on carbon emissions. Otherwise, there will be no economic incentive to trap and sequester carbon, just as there is no economic incentive to treat waste sewage water before throwing in a river. So I've drawn on long enough, so let me leave you with one final bit of advice, and that is, you will never please your mother. As was said, I grew up in a family where education was not merely emphasized, it was the reason for our existence. Virtually all my aunts and uncles had advanced degrees in science and engineering, and it was taken for granted that the next generation of Chews were to follow in the family tradition. All my cousins have PhDs or MDs. Indeed, my 2 brothers have between them 5 PhDs, an MD, and a law degree. One is now a wildly successful lawyer, and the other is a university doctor researcher at Stanford University. So in this family of scholars, I could only manage 1 degree, and indeed, I am the academic black sheep. In my family, there are 3 career choices: doctor, lawyer, failure. When I heard the news that I was awarded a Nobel Prize in physics, I called my mother that morning and said, "Mom, guess what? I just received the Nobel Prize." To which she replied, "That's nice. When are you coming to visit me next?" In my family, getting a Nobel Prize only leveled the playing field. So I end, thank you again, and to the graduates of the class of 2007, congratulations. Mazel tov.